Right, I don't know if this is going to work. We'll give it a go. I was told that, in fact, I should have carried on with his V-block clamp video. So we're back with Fab Life. Now, seems a bit like picking on somebody, but this guy really is full of errors, and his stuff's beautifully filmed, but it's junk. And he deletes comments, which I kind of intimated at in my last video. You'll notice that this has got 13,000 views. There are only 68 comments. Now his upvotes are pretty poor for 13,000 views, but 68 comments, that's lots of people getting zapped. I know because one of my comments was zapped. But here we go. So I've been into this up to a certain point, and then I stopped. So I'm now going to give it a go all the way through. We're running him at 1.75 because life's too fucking short. What happens if we go full screen? Do we get full screen? I hope so. The main problem with this is going to be that his stuff is 1080 60 and my machine struggles with 1080 60. Yeah, that appears to be working. Let's turn off the preview. How do I do that? Hang on. Not there. How do I turn off the preview? Enable preview. So turn off the preview. There we go. That should speed things up a bit. Right, let's get into it.
These are my latest creations on my channel. 2 weeks ago I made these V-blocks, but due to how long they took...
Oh, now then. What we can see here is that he's finished them, which looks to have been done on a linisher or, yeah, probably a belt sander or possibly a disc sander. That's a horrible finish. And those, look at those glorious chamfers, they're enormous. Especially the ones on the functional edges. Those are a bad idea. You should have just, taken those off with a file. That would have been a much better idea, because those are functional edges, and your clamps are going to need to work on them. Now he does mention, I don't know if it'll show up here, but this involves sponsored content.
To make. I said that in the next video, I'll make clamps to suit them. So in saying that, because I'm a man of my word, this video is how I made myself a V-block clamp. Yes, I meant to say just clamp and not clamps. You'll find out later in the video why it was only possible to make just one for now. Anyway.
Only possible to make just one for now.
With that said, let's jump into the video. Most of my projects are just made with using leftover materials from other jobs. The body of the clamp will be...
Nothing wrong with that. I don't think it's the right material, but then he wasn't using the right material for the V-blocks either. The V-blocks are made from mild steel, which is really not the right material for any kind of metrology equipment, but there you go.
Made out of 12mm hot rolled steel plate, which is probably not ideal for this application, but...
Oh yeah, that's fair enough. No, it's not ideal for this.
I believe it will work just fine. If you're anything like myself, figuring out where to start with projects like this can be a little overwhelming at times. I find myself needing to see something drawn on paper or modeled in CAD software before any cuts are made or any metal chips are sent flying around. So this brings me to this video's sponsor, Onshape.
Yeah, go on then. All right. Let's find the end of his Onshape thing, shall we? Right. Actually, no, let's not, because so he's going to be punting Onshape, which is an online CAD program, I think.
I've spent countless hours or probably days learning CAD programs, but none compared to this one. In just one afternoon, I switched from my old software and created this incredible 3D model of my V-block clamp. The program is incredibly intuitive, menu and design options are easy to find. Another thing to point out is that there are no installs, no downloads. It runs entirely in your browser or on the mobile app.
Oh, well, that's a good idea, isn't it? Having everything online. Right, now then, what can we see here on his design? Well, hang on.
Just log in and start working. For instance, this relieved me of the never-ending software crashes and updates that would get in the way of being efficient with my workflow. There is no hardware maintenance required. All the heavy calculations like complex...
Right, I don't give a toss about Onshape, but let's have a look at his model. So we've got a knurl here that's useless, because he's put a Tommy bar through the middle of it. That is, that's pointless exercise. Maybe he'll do it, maybe he won't. There's a reason why most V-block clamps, sorry, I'm full of cold, are circular. That's because you're going to be clamping round stock in here. So what you want is the biggest round that you can get in here that goes to the edge of the V-block, which is going to be, I think, if I remember correctly, something like 50 mil on his model. You want a 50mm circle here. Yep. That doesn't look like it's going to fit. There's the other fact is that because you're clamping, you want enough space for the end of your clamp to allow that 50mm space. So it looks like he's done it too short. And in fact, that whole big end thing, unless he's sinking it into here, that's possible. That would be a reason why he'd got this thing up the top. Yeah, if that sinks into there, well then that's fine. Also, that's not great for stress risers, but he's got nice round corners, so you know, it just seems like a waste of material. Normally, you know, they're made from a piece of bent bar that's been just a couple of bits, you know, forged over on the end of it. But you know, okay, yeah, I don't like his design.
Complex features and large assemblies happens on Onshape's service, not your computer. This means that you can run full professional grade CAD on basic Chromebook, a Mac, a Linux machine, or a tablet. So if you're an engineer, definitely check out Onshape using this clamp. So starting things off, I need to cut off the ends of this flat bar. The process in which the metal company has cut these has left a rolled edge.
What I don't understand is why he's not taking it out of the wonky end already, but there you go. He seems to be taking stuff out of the good end, leaving himself a smaller piece of material that's going to be useful. Also, we don't need to see you tightening up the vise.
Remove that portion. I'll then get into marking out where the next cut
or pushing the buttons
will be.
And if you can do this, you've got a mill, surely. Why don't you just cut this off, mill that flat? You're going to have to mill the edges anyway. But, yeah.
As slow as this clip seems, would you believe that it's sped up by 8 times?
It's more than 8 times now, because I'm running you even faster. What a lot of fucking filler. Cutting stuff with a saw is not interesting to watch.
I'm not sure if the feed rate was set right, but I can tell you that I could have almost had a nap waiting for it to complete. In saying that, it still beats using a hacksaw.
Everything beats using a hacksaw.
The main body of the clamp will be 80 by 80 millimeters, so I'm marking out
80 by 80 to go around a 50 by 50 block. Yeah, okay. 15 mil either side, that's quite a lot.
5 millimeters to allow the machining process and for future mistakes.
Ah, right, so 10 mil either side. That's still pretty fucking beefy, but hey, 10 by 12, yeah, that's all right, I guess. But still, you shouldn't have taken it out of the wonky end. Because there's a lot of waste there. Still, using a square, that's all good. Yeah, look at those chunks that you can throw away. Wow, that's throw away, you put them into you. That might come in useful. Okay, and we need to see this whole thing cut as well, don't we? Fuck off. Yeah. Change your camera angles. God almighty. I suppose you've got time to change your camera angles while that's going on. We don't need to see it.
To connect with the real process.
Oh, hang on.
I'm never quite sure on how much to show and how much to speed up. I feel that showing more of what goes into the projects allows the viewer to connect with the real process and not some fantasy that projects like these come together super fast with minimal effort. Let me know.
I would let him know in the comments, but he deletes comments. We don't need to see every saw cut.
In the comments down below what your thoughts are.
Positive. Yeah. Come on then.
Here you can see why I left extra on these cuts. There is a bunch of deflection from the bandsaw that I will need to machine away to make these two plates a matching set.
Deflection from the bandsaw. Ooh, that's not good. No, what you mean is that your bandsaw doesn't cut straight, or you can't set stuff up properly, which is, you know, okay. Now you should really be gang milling these, which this is what you're doing, but what you really want to do is just glue them together. You know, super glue them together. But to do that, you need to get rid of all the scale on the outside first. Best way to do that, chuck them in vinegar overnight. That will remove all of the mill scale, and you'll get something relatively flat. Now, this bit here, squaring them up, you don't need them glued together, because you know you're going to need to surface one face of each at least before you glue them. So you could square them up, descale them, skim them with your fly cutter, because he's got a fly cutter and he likes to use it, and then glue them together to do the rest. That would be a reasonable way to go. It's not the way he goes, but hey. Now at this point he is effectively climb cutting this edge, and that's why he's getting vibration. This is, like I've said, it's a Chinese round column mill. It's not very rigid. He's end milling with a roughing end cutter. That's fair enough, and he's not going in very deep, which is fair enough because the machine isn't going to like it if he does. But yeah, he's climb milling here. Should be coming in from this end. That's all this may be though. Brush those chips off. Hey, are you going to deburr that? No? Okay, good man. Knock it into the vise to make it square. Buried. So again, that was a bit of climb milling when he came into this wonky end here, but again, not really a problem. Now, what he should have done at this point, well, we'll get on to what he does. He's assuming that he's square, and he's not square. What he should have done at this point is chuck them in on parallels, but you'd have to do it individually. So you chuck them in on parallels, surface them up, and this is the point at which you glue them together. This end looks to be slightly longer than this end, but it shouldn't really be, because he said he wanted them square. These ends are now not going to be square to this, because those ends aren't square to this. Nothing's square. If you lock these ends into the jaws, which are theoretically parallel, you can leave them hanging out and side mill down the side, and then you'll have stuff that's square. But his stuff's not going to be square, is it? Have two parallel sides. There you go, climb mill down. Now this nasty burry stuff is because it's A, because it's mild steel, and B, because he's left the mill scale on. Mill scale's nasty stuff. And if we go back 2 seconds, you'll notice that these sides, are they the same? Yeah, they are. These sides, which he has theoretically milled to be parallel and the same size, are no longer parallel and the same size, because he's not paying attention to what the fuck he's doing. those ends and those ends, after milling the other two sides, should now be 100% square, and they're not. So something has gone wrong already. And you'll notice that here we don't match up either, and we can see a bit of edge in there, so we're not deep enough.
Now that I have myself two matching plates, one
You don't have two matching plates. You have two plates that you think are matching. You haven't measured anything. Right, so at this point, you need to take this fucking mill scale off. You're going to have to take it off at some point, and you're probably going to leave it until the end and take it off on a sander would be my guess. But you should have taken this off, glued them together, and gang milled.
will need to take the sideline while I machine the center out of just the one, and then later repeat the same process on the other.
Yeah, you should be gang milling this.
In my CAD design on Onshape, I designed the clamp to have a 10mm body that will surround the V-block. Here I am visualizing how it will look with the V-clamp and the block together.
So you don't trust your model. That's fair enough, because your model's shit, but see here, I don't know if he's going to, let's see what happens if we go forwards a bit. No. The circle for here is not going to fit in that space, so you're never going to be able to hold the biggest work that you can clamp in these V-blocks with these clamps.
Even with pre-designing in CAD, sometimes in real life it doesn't look the same as it did on the computer screen, so it's always better to just double check before diving in.
Yeah, go on, bend that fucking scriber, scribe it twice, go on. You're not going to finish your scribing lines anyway. You're not going to follow your scribing lines. Your scribe's really way too hard.
With all the scribing out of the way, I'll now move on to machining out the center of where I've marked. I'm not sure if plunging with the end mill was the right move, but from what I've researched, it said that it was a suitable process and just to take it slow. I'm sure that I'll find out in the comments whether it was the right move or not.
Now this is the point pretty much where I stopped watching. So he's saying he's going to plunge through this with an end mill. Now there's all sorts of things that could go wrong with this, but hey, get that parallel in there. So, didn't see him knock it down square, so it's quite possible that these aren't going to be square. Now he's going to plunge in here with what is probably not an plunge cutting end mill. 4 flute mills normally aren't. None of my roughing end mills are end cutting either, plunge cutting either. So what we've got here is a bad idea. Now, it's a bad idea for a lot of reasons. First one is that the easiest way to remove material and the fastest way to remove material is with a saw or an angle grinder. Now, you can't get a saw into this hole easily, so you have to use the second one. The second option, second fastest option, is a drill. Drills are made for removing material in a plunge method. So you take your end mill out and you just gang drill it. Now at that point you could actually make the circle here for getting maximal material if you've got a reasonable design. You could also do that by drilling a big hole here and doing it on the lathe. The lathe would be a very good way of making the interior circle here. It wouldn't be a good way of making the exterior circle if you were wanting to make an exterior circle, but the exterior is irrelevant. Another way that you could do it would be using his DRO. Even the cheapest Chinese DROs have circle cutting abilities or bolt hole circle setups. So you could drill a hole and then you could nibble it out as you go around with an end mill. And at that point you're not plunge cutting because you're only cutting with a part of the mill. This end mill here is probably not plunge cutting, as I said. He probably wants a slot drill which has 2 irregular length flutes, so it actually cuts in the center. I don't know whether this plunge cuts or not. We'll have a look actually. The next thing he's going to do, obviously, is try and cut out to his lines, because I guess he's not going to be using his DRO. You should be using the DRO for this. Once you've gone down, it's actually not too much of a problem. I mean, it's bigger. A better idea would be to drill as big a hole as you can, and then work your way around in the same way that what do we call it? A CNC lathe would do, mill would do it, which is to say that you go around and around and around and around, so that you're only cutting on one side of the mill, of the milling cutter. In this case, you go the other way to the way that a CNC would do it, so that you're conventional milling all the way. Because again, this machine doesn't have the rigidity or ball screws with zero backlash to deal with climb cutting, especially not with a roughing cutter in horrible sticky material. And what I hope he's not going to do is try and come through here, because if he comes through here, where his little feet are, if he comes through here, this whole section is suddenly non-supported. So the way that I would do this, I'd find the centre of the bit that's going to be above the V, which you do by some calculation. I'd pop a spot in it. I'd chuck it in the lathe, centre it onto that spot. You put a centre pop in, and I would use the lathe to take out a circle. Otherwise, you do it on the mill, but you nibble it with an end mill, all the way around, and then take out the rest of the material with the roughing cutter, or a normal cutter even. Once you're down to nearly here, you leave this bit on its own, and then you just cut them out with a saw, or worst case, you stand them up on end in the vise and cut them through. But I'd be ganging this anyway. So let's see what happens. Now I'm going to go to normal speed here. In fact, I'm going to go to slow speed, because I want to see what happens when he plunges in. So half speed. Now, that was the bit it all went wrong, I think. That was definitely vibrating. Now, can we see the centre? I'm going back here, because he lifted up slightly, just there. I'm going back frame by frame, which is probably not the smartest move. Let's go back 5 seconds and see what. So there it was. Can we see the centre? No, okay. There we go. Right, okay, you've got a pip in here. So that's not a centre cutting milling cutter, which means that it's going to be jaggering about, and it's having a hard time cutting that centre. It's basically just pushing the material out to the sides where a bit of the cutter is doing. He's probably having to push quite hard on his quill. So let's go back to a more sensible speed for this video, because an awful lot of it is filler. Now you can hear it vibrating. At least this time he is using some lube, which is not a terrible idea. You can see the horrible chips that are coming out, but then, you know, he's plunge cutting with a roughing end mill, so in horrible material. Now he's going in quite hard because that's a high-speed steel cutter, and those chips are coming out blue. What he could do with here is an air feed that just puts a trickle of air into the end of the mill. You don't actually need lube, just something to keep things cool and blow the chips away. But hey. So, brush the chips away, lots of. Now, this is the point where the first cut's going to be nasty, because as you push in, you're cutting on the two sides of the milling cutter, which the forces equalise themselves out. Slot cutting is nasty, but the front of the milling cutter is trying to pull things sideways, so it's spinning around this way. Let's assume it comes this way, so that I can point at the front of the cutter. The front of the cutter is spinning this way, which means that it's trying to push the milling cutter that way, and it's trying to push the work that way, so you get a lot of vibration initially. So what he really wants to do is come in so that he disengages from this back side and then start spiraling. Oh. Okay, we did move that way, that's good. That starts spiraling in this direction so that you're only cutting on one side of the cutter. You can cut a lot deeper, and you're using the cutter like it's supposed to be used. It's not a slot drill. I just want to brush those chips away. So you get a lot less vibration, and you've got a better chance of hitting your dimensions. Oh, good boy, he's slotting it. Okay, right. This is done. His machine is. You can hear the noise there at 175. Let's just go to normal speed, shall we? Just for a couple of seconds. Just really appreciate this. He is slot cutting, so he's going to try and slot cut up to his line, probably, or fairly close to his line. But the thing is, his cutter's trying to deviate, so that's going to be fun. This is why when you cut a slot, you use a smaller milling cutter than you wanted the slot, and then you go in and you clean up on either side. You're only cutting on one side, and things are much cleaner. So now that's his speeded up footage, and you can hear it vibrating like a motherfucker. Because this is 1x speed on his video. This is the dumbest way to do it, but hey, maybe he'll come back on a, probably climb cutting, but come back on one side. Let's see. Let's go back to 175. We don't need to do it. Right, and yeah, let's go. Oh, he's gone right up to the line. Well, that's a good idea. You're using a roughing cutter. A roughing cutter is going to require, even if you were doing this properly, it's going to require cleanup. So he's already blown his dimensions. Now we know he's got a DRO. He could have used his DRO to do this, and not really had to bother with the lines at all, except just as a dumb fuck indicator. Now let's hope he's not going that way. No, not going this way. So if he goes this way, his cutter is going to want to come this way. Beep. And that's not going to be fun. For slot cutting. Jesus Christ, you can hear it suffering. Oh, that one's going to have gone the wrong way. I suspect he went that way to try and finish his line, and his machine complained so much that yeah. Now that little suffering there I don't know if you noticed why that happened. That happened because he changed his camera angle. Let's go back. So, he's messed up his corner. Now that's where he stopped. He's changed his camera angle, and he's probably left it spinning. And, oh look, a great big guff in your work. This is part of the problem of worrying about the filming rather than the work. He stopped again there to brush his chips away, so he's probably got a guff on that side as well. We'll see in a second. Yep, there it is, nice little guff. That's because as he's cutting, now at this point he's cutting on one side of the cutter and things are chattering a lot less, despite the fact that he's climb cutting. Now, what was I saying? Ah, yes, the guff, he's got a lot of clean up to do here. The reason that those guffs happen is because when he's cutting in the slot, it's trying to pull things away, and then as he stops, it allows it to deflex and just clear the chips away and deflex back to where it wants to be, according to the geometry of the machine. So yeah, you will get guffs, and then as soon as you start cutting again, it's going to pull away. Now it's going to chatter a bit here because he's climb cutting, but it's going to chatter less than when he was slot cutting. Oh yeah, there we go. Nice bit of chatter there. Oh yeah, and stop with your cutter in contact with the work. That's always a good idea as well. So we've got a nice guff in that corner. We've got a nice guff in that corner. We've got a great big guff in that corner. One here. A nice one here, and a nice one here, and look at the state of that. It's roughing, it doesn't really matter, but what it does mean is that he's going to blow his dimensions by quite a lot, because he's come up to the line here and here more or less, so he's going to have to go further. He's going to have missed his marking by a long way. And he's probably going to climb cut this, and he's going to get a shit result. Oh yeah, hear that chatter. So, conventionally milling, and then he's going back with a climb cutting pass. If it's just without moving the dials, you'd probably get away with it. So, that is the finish you're going to get if you're climb cutting, which is what he's doing, with a conventional mill and it's sloppy. You're going to get a shit result. And there we go. He's actually conventionally cut that one, and you look at the difference in finish. Now, climb cutting is supposed to give you a better finish, and that's because on a very rigid machine with ball screws, you can do it. You've got very, very little flex, and it clears the chips out underneath the cutter and throws them away. You also need to have something blowing the chips out. If you're conventionally milling, you're pushing the chips out the front and you risk recutting them, and that's why you get a less good result in theory. In this case, climb cutting gets you shit, conventionally milling gets you a much better result and a lot less chatter. Now, what's he done? Oh yeah, he's properly blown out his dimensions here and here. That side looks a bit better for the moment.
Thank God that's done now. I really struggled with machining the internals of that cutout. The end mill just kept screaming at me each time I went around the inner corners.
Funny that. If your machine is screaming at you, either you're doing something naughty and you know it, and you just live with it, or you're doing something very wrong and you're making your machine suffer. You'll notice that the vibration has caused his parallels to move. That could be causing problems as well, because they could be clipping on his cutter. That's because he didn't knock his work down.
Let me know in the comments down below of what you think the chatter was from.
And you can see how easily he moved it. That's not down tight.
Regardless of how deafening the sounds were when making this, I think it's turned out just fine. And you know what?
Just fine. You're at least 1 millimetre off your marking lines on either side. You're probably 2 millimetres off on this end. So yeah, just fine. You've absolutely made your design.
That means I can move on to the next process.
Still, he didn't do a dumb and try and do this cut in that setup.
Once I double check things, I can then mark the portion in which I'll machine out. This will leave the 2 legs that will tightly fit the sides of the V-block.
Right, okay. So you're just going to... Oh, you dumb fuck. Right, first thing, you don't need to machine this shit out. Angle grinder, hacksaw, bandsaw, any of those tools will do this much, much faster than this. Secondly, like I said earlier, you're clamping here. Okay, he's putting it into the middle, which is at least a start. But he's put his work into the middle and all of the clamping load is going through here. As soon as you cut through this, none of this whole section here is supported because this wants to flex in, this wants to flex in, you've got no support here. So there's 2 things that can risk happening. One is that one of your legs will jump in at the point as you go through, catch in the milling cutter and the whole thing will go blam! And the other one is that your milling cutter is trying to pull that piece of work up and suddenly it's not supported. So the whole thing pivots around here and goes zip, upwards towards the vertical, which is a very bad result as well. Both of these are broken end mill land. The way that you should be doing this is you should be standing it up vertically in the vise and just milling through it. At least that way it's supported. It'll sing a bit, but it's not too bad. And especially if you've just cut these off, all you need to do is skim them. Christ almighty. This is a really, really bad setup. And we haven't seen him knock it down, so you'll probably get a lot of vibration. You'll see those parallels dancing.
I think this carbide end mill is almost ready for repurposing.
No, you're doing a stupid. Because on top of that, let's go back. You've got a great big hole here. You're plunging in with a non-end cutting end mill. You come in here, zoop, zoop. You don't need to machine this bit. Slot cut through, but you know that material shouldn't even be there. But you're plunging in, you dumb fuck. It's not made for plunging in. Come in on the side.
I think this carbide end mill is almost ready for repurposing.
This really is all sorts of fun. Right, okay, and we're going to go back to normal speed because I'm expecting a disaster here. So at least this time he's coming down outside and milling across, which is the way to go. Okay, you can hear it chatter, but he dodged a bullet. Okay, well, that's good. Again, he's not worried about whether he's conventional milling or climb cutting. It doesn't matter to him. He's dodged a bullet there, though. Fuck me. He's now milling on something which is not supported. And you can hear it chattering. You jammy cunt. Let's go back to Full speed.
As basic as this looks, I can't help but feel a sense of accomplishment. Time to check if this will actually
Sense of accomplishment. Well, at least he's put a little bit of a. He's deburred it.
tightly fit the V-block.
And he appears to have more or less hit his dimension on that. That's fair enough.
Hell yeah, how good is that? It's a small step for some, but for me, it's massive. Now it's time to
It's a very small step.
move on to the threaded feature of this part.
Right, I'm just going to pop a threaded hole through it. Fair enough. Yeah, more scriber abuse. Yep, all scribe twice. Always good. Measure once, scribe twice. Oh, only once.
Here I am drilling and tapping for an M8 thread. This will be for the future.
Has he put a centre pop into that? Doesn't look like it. I think that's just the intersection of the two scribe
That will pass through and it will push down on whatever is being cleaned.
Yeah, that's just the intersection of the two scribe lines. No centre pop. Okay.
In the V-block.
And that is not a centre drill, and it's not a spotting drill. Either of the two would be acceptable. What's going to happen here, that's just a normal jobber drill. As soon as he hits here, because he's got nothing to centre it, it's going to skate. The tips of drills are never 100% hitting with both tips at the same, both edges at the same time. Something is going to be very, very slightly off, and it will skate, which means that it's not going to be on centre. And because he's doing this in a relatively stiff machine, that drill is going to wander. It's not going to go straight down the hole he wants. So what you should be doing is going in with either a centre drill, is a reasonable approach, but a better one is an actual spot drill, which has a slightly wider angle than the jobber drill that you're going to be using. So the spot drill goes in, it's very short, it's very stiff, and it doesn't skate. It relies on the rigidity of the machine to put the hole in the right place. To put just a little tiny hole in there, and then when your normal jobber drill goes in, it's not running on the flutes, it's running on the centre, and it's centred. You'll notice on CNC machines, even if they're putting a tiny little hole in, they have this massive fucking spot drill. You know, you might be putting in like a 3mm hole, and they'll be using a 25mm spot drill to spot it. Only a tiny spot, but it's rigid, and it doesn't move, and it makes sure that stuff is going to be in the centre. So this is going to move. It's not going to be centred. And you can see it do it there. Let's go back. There. There, the drill has bent. So it's come off in this direction somewhat. Right, okay. So he was pilot drilling it. Pilot drilling is not a bad idea, but on something this size, I mean, that's what? I'm guessing he's going for M8, so that's what? It's a 7 point, not 7.6. It's probably a 6.5mm drill that he's using here, because nobody's got 6.7mm drills. 6.7mm drills for tapping, they don't exist, do they? Oh yes, they do. I bet he hasn't got one. I reckon that's either a 7, which will be undersized, which will be oversized for the tap, which means he'll get undersized threads, or it's a 6.5 and he's going to have trouble tapping, especially chewy, mild steel. So that would have followed the pilot drill fairly accurately, which means that that would have bent as well. Ooh. Nice, come on, brush the chips off. Good boy. Now, what we can see here is that the chamfer on this side is bigger than the chamfer on this side. Why is that? That's because your countersink drill is stiff and rigid and it's going to go straight down, and your other drill has moved. Okay. You can see it again. Oh, fuck me. Brave boy. He's power tapping with a hand tap. Excellent. See how this goes. Maybe he's probably just going to feed it in and then hand tap the rest. That would be the sensible way to go. Let's see how it goes. About as well as I expected. That was a 6.5. That stalled out completely. So he's got his it looks like it's in a drill chuck as well. That's not handy. But okay, you let go of your drill chuck, stick your handle on there, and away we go. Or you tighten up your drill chuck and power it out. Okay, well, you've got enough thread in there to be able to feed it back in. Oh, you stupid cunt. Right, okay. This is very stupid. So he's cut a number of threads in here, not very many. It didn't go in very deep before it stalled. So what he's done now is he's gone out, and he's tightened his drill chuck, and now he's re-power feeding into the same hole. Now, there is nothing to make that tap go down the same threads that it's already cut. So he's recutting threads, and we will see. Yeah. So he's basically mullered the threads at the top of this hole. Stupid fucker. I mean, as soon as it's jammed, either you tighten it up and you leave it in the hole and you restart under power, which is going to put a lot of load on the machine at the start, and risk snapping a tap, or you just do it by hand. It's only an 8mm tap. Actually, it might be a 10. What did he say this was? 12mm? No, it could be a 10mm. Whoops, whoops. Nice. So he's power tapped a wonky hole and mullered the threads. Good man. You can't really see it there, but yeah, I'm certain that those threads are not good.
Well, you guys just witnessed me power machining with the mill for the first time ever. I do have a tap chuck that is specifically for this on my wish list, but Santa is still a while away, so the Jacob's chuck had to step in. Next up, I'm going to machine the top corner so that the tool looks a little more fancy. I mean, I could leave it the way that it is, but it looked nice when I designed it in CAD, so I'm sure it will look good in real life.
Yeah. It looked great with all that mill scale on it. Nice.
I'm absolutely loving this new tool that I use with the scribe. It has two benefits. It really helps with accuracy, and it also stops me upsetting people when I use a cheap set of calipers to scribe lines.
Yeah, cheap set of calipers to scribe. Lots of people do it. No big deal. Oh, and now you're doing it how you should. That's how you should have done the hole at the bottom. But never mind. Right, he really needs to learn about the difference between climb cutting and conventional cutting, and cutting against the backlash of the machine, and because he's just not paying attention at all. I think he's bored at this point.
Finally, it's time to now move on to using the lathe to create the main bolt. I feel like
to create the main bolt. Now this seems like busy work because surely just a bolt would work.
it's been forever since I've used it, so let's see how many dumb things I accidentally do while finding my groove again.
Well, focus is a good start. tight. You can hear it suffering. Something's not tight. I reckon it's probably his tool holder is not clamped down properly. That didn't move, did it? Oh, look at those apprentice marks. They're nice. Lovely. They're nice. They're good. He's not breaking chips, which means he's either not feeding fast enough, or feeding too fast, or perhaps his tool's fucked. The tip doesn't look very healthy, and he's about to get into a situation where he can't go in any further. He's going to have to change tools or change angles. He's got too much stick out on the tool already. Still. All going all right so far. It's a bit tedious, but here you go. Oh yeah, change tools. It's getting a better finish with this one as well, so it's probably the tip. Better finish being relative. This is still mild steel by the looks of it. Look like hot rolled. This would be much better done with just an 8/8 or 10/9 bolts. You pop a hole in the end of it, stick some braze in the end, clean it up, bish bosh, job done. But you can measure. That's a brave chamfer. It's poking out a long way and it's not very big. Still, it's only a chamfer, I guess, so, you know, it looks like he's got a sharp tool. Yeah, you can see it moving as he tries to cut. But as long as you're going gently, you'll be alright. Yeah, you can see it flex. It's a fairly aggressive chamfer. You're gonna single point this?
So far, so good. I don't know why I like chamfering with a bunch of stick out. When I look back at the footage, straight away I can see how terrible it looks. In person, it's barely noticeable besides the sounds it makes when it's not happy. It's an easy fix, guys. Don't zoom in and watch back your machining processes.
Alright, okay. So he's not going to single point it by the looks.
Here I'm using my shop-made die follower that will be used to cut the M8 thread. This tool has been such an asset to my shop, and I strongly suggest you make one for yourself. I do have a video on how I made it if you'd like to check that out also.
Die follower is a reasonable plan. Some goop on there, yeah. Okay. That's all? Okay. That didn't look like he was... Yeah, okay. I hope he gets lucky with that, because it's got the same problem as power tapping. There's actually more chance of hitting it with a die though. Okay. Yeah, he did. Okay. If you're going to part this off, you would have been better off just buying small thread, but I suspect it's just putting a relief in there.
How satisfying is it to watch the die follower do its thing? Now I'll move on to the
Yeah, so it's just a relief.
head of the bolt. This will feature a knurled face, so fingers crossed it all goes smoothly.
Oh, he's going to do the nail. Good man. Waste of time, but hey.
This scissor knurling tool is also something that I've made on the channel. It does such an amazing job and it really doesn't stress out the lathe too much compared to the bump style tooling.
This is a nail for all right. There's some lube on there. That's all right. So this is all a waste of fucking time. A stock cap-head bolt, you can put a knurl on it and use that for threading stuff in, and just pull out a hex key when you want to use it. So that doesn't fill up your video, does it?
With the knurling done and dusted, I'll now move on to drilling the hole for the slide handle. Now I'm pre-warning you that this didn't really go
Now drilling through this is dumb. And he's got a spot drill. Look at that. A stubby.
to plan, but I was committed and I got there in the end. I don't
Ooh, that's bending, isn't it? Now either your nut's not done up tight enough, or your material's too soft.
think that the collet setup was a very good idea, or I should have had some support under it before starting.
It is a spot drill. Now, that's the spot drill he should have used earlier. And yes, he should probably have some support under here because he's, yeah, it is 8mm, isn't it? Because that's a 7 to 8 collet. Okay. But this is all kinds of dumb. Yeah, that's not done up tight enough. Didn't expect to see that amount of reflection. But the other side's going to look nice. Yeah, it's well off. Chewy.
This next part is the slide handle. I don't have any small steel rod on hand, so I will machine this down to an 8mm diameter.
You can't find any 8mm rod. You can't just go to, I don't know, what is it, Bunnings in your land and just buy some 8mm steel. Yeah, well, piss with the cock you got, I suppose. Looks like a pretty big lathe. Oh, you're going to fuck tips up doing that, boy. Right, let's... when he was facing that, his tip went sort of to about here, which means that the other edge of this vibey rod is pulling the cutting edge up. And that's how you snap the ends of tips off. Oh, do it again. Oh. I'm not sure if his headstock bearings aren't fucked, to be honest. It seems to be making an awful lot of noise when he put pressure on with the with the drill and with his centre. Again, he's not breaking chips properly.
I felt myself slowly finding my way to Struggle Street. I kept struggling to get the tips to break properly.
Okay, he's realised it. That's fair enough.
And once again, more razor sharp bits of metal ready to get thrown around by the chuck if I'm not quick enough.
Yeah, now breaking chips with mild steel is nasty, and I suspect it's because his tip is not adapted, or it is fucked. Give the surface finish, I'd say it's the tip.
See what I mean about Struggle Street? I don't even know what I did wrong. Somehow it pulled its...
Well, I know what you did wrong. You engaged the power feed on the wrong slide. you were feeding in, not feeding across. That's you got quite lucky of catching that because you nearly snapped stuff. You've also got a lot of stick out on this tool again. It's probably to try and clear the tailstock, but oh no, that was bad. I want to see that again. That was fun. In fact, let's have that at normal speed, shall we? I can't believe you showed that. Fuck me. It took you a while to catch it as well. Bloody hell.
See what I mean about Struggle Street? I don't even know what I did wrong. Somehow it pulled itself inwards whilst having the power feed engaged.
Somehow it pulled itself inwards while having the power feed engaged. Operator error, my friend. It's always operator error. You're the operator. In fact, operator error would be your name if you were in the military.
Off camera, I said a few bad words and regathered myself. I then quickly cleaned up my mess and continued on.
All that to make a piece of 8mm rod. Jesus Christ.
For these next steps, I'll be drilling and tapping for an M6 thread. This will allow me to screw on the end caps that will be made soon.
Nice. Ooh, you're going to be powerful. So, by my count, he's got maybe 2 threads of engagement, given the depth of his chamfer and the depth that went in. 3, if he's lucky. His hole's not deep enough, and he's using a tapered tap. You are a fucking brave man doing that in a keyless chuck. Just realised. So he's got a keyless chuck here. The way that keyless chucks work is that when you tighten them up, the jaws turn. It's the difference between a keyless chuck and a keyed one generally. So when this starts spinning in the chuck, or in fact when you're putting torque on this, it's trying to tighten the chuck up. And that's a good way to snap a tap, because you're relying on the chuck to slip when you get to a point where there's too much torque. But if that's nipping the chuck up at the same time, you can end up where it's just going to tighten the chuck the fuck up, and bing! These things just love to snap. Okay, it's 6mm, which is not tiny, but hey.
Now for my favourite part, the brass features. Although this stuff makes a horrible mess, I absolutely love how good it makes any project look. But there's one catch. It would really help if I'd switch the machine back to rotating in the correct direction after backing out the M6 tap.
Oh dear, you're spinning it backwards. Good boy. At least there's a bit into it. Yeah, that's going backwards. But you know, he's admitting it. I'll give him that.
Even after all that, I still hadn't figured out what was wrong. This is definitely a shameful moment. Now that I'd figured out what was wrong, I then flipped apart and continued on like that didn't ever happen.
Well, why not just clean up what you've just done and carry on? Oh, much better finish there. Not great. Actually, looking at the finish, that tool's very wrong. Because you can see the shiny finish that you get here just with a cut-off tool. That's a fairly gnarly finish for brass. You should be able to see your face in it, really. So basically the tool that is used to turn this down is the wrong one, or it's got a buggered tip given the finish that he's getting on there, because you know it should be mirror finish like that really. If these are the end knobs, why are you drilling them? Presumably he's going to chuck a piece of all thread into both holes and glue them together that way. I don't know. That's a bit of a daft way of doing things. Surely he could have just put some thread on the end of the rod rather than threading a hole. Yeah. Afraid to power tap this one though, aren't you? Yeah. Yeah, this is dumb. He should have just, you know, put his die follower on and you know, done a 6mm dyed thread on the end. He's going to have to. Yeah. This kind of work is what collet chucks are made for. You cut your pieces off, you know, chamfer, cut off, chamfer, cut off, chamfer, cut off, chuck them all into a box down here. Then you chuck them into a collet and you go drill, 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 and then you chuck them all back into a collet and you go tap, 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 tap. But there's only 2 of them, so you know.
So you're probably wondering what these 2 parts are. These will be the tips for the handle. I will also make one extra that will be for where the end of the bolt will contact what's being held in the V-block.
getting a shitty finish. Look at that fucking tool, it's horrible. And look at the finish it's giving you. Right, the angles are all wrong. When you're doing brass, bronze, you want an angle with a 0 degree rake here. And you want a nice big round surface, big radius on the end of the tip, and you'll get a lovely finish. With something that's aggressive like this, you're going to get shit results like this. This is all sorts of
And just like that, we are finally at the stage of
Sorry, what was that last piece of footage all about? You missed the bit where it fell into the pot and just showed us rubbing the end. Rubbing the end.
And just like that, we are finally at the
You have taken the scale off. So you've rounded over all your edges really nicely by putting it onto a belt sander or a circular sander. That's a horrible finish. Learn to file.
stage of assembly. Comparing the end result to what I'd designed in CAD, you will notice that I'd changed a few details. The reason behind this was that I really didn't feel comfortable risking having to remake any of the parts as I'd broken my lathe. In a careless move, when polishing the brass, I'd slid the carriage away to the end of the ways and didn't realise that I'd left the power feed engaged from the last parting off process. This resulted...
Oh, you dumb fuck. You've proper fucked that, haven't you? Oh dear, oh dear. Oh, wow. 2 lathe crashes in one video. That's fucking brilliant. Oh, thank you very much. Now, have you snapped a casting? Have you snapped something in the lead screw? That could snap a casting. Fuck me. You could shear off the... Oh, man. I hope you haven't, but bloody hell, well done. And presumably you were there. This is why people like you shouldn't have a power feed. Fuck me.
in the lathe moving inwards until it maxed out and broke either the lead screw or something.
Right, hang on, let's see what he's got to say about this.
Having to remake any of the parts as I'd broken my lathe. In a careless move, when polishing the brass, I'd slid the carriage away to the end of the ways and didn't realise that I'd left the power feed engaged from the last parting off process. This resulted in the lathe moving inwards until it maxed out and broke either the lead screw or something else that remains unknown. In the next video,
Something else that remains unknown. Oh dear, you fucked it.
I'll be finding out what's wrong and I'll be doing what's needed to get it up and running again. Anyways, let's continue assembling this clamp. These are the two end caps for the handle. I will be using 2 bits of M6 thread and will be Loctiting them in. I didn't trust myself.
Yeah, you could have just, got some threads on the end here, really.
In making an M6 thread without having to scrap something and start again.
Plenty of Loctite. So, your hole's not centered on your knob. The nails are useless. This knob, there's no way that's going into that hole, so that's going to cut off another, what's that? 10, 12 mil of travel. So another 10, 12 mil of diameter in your V-block. Well done, you.
Now that it's assembled, let's see what it's like connected to the V-block.
Yeah, let's. Look at those glorious videos.
That is so satisfying to see how well they fit together.
Yeah, you're going to be able to hold something that's maybe the diameter that you put in here. You might get, what sort of diameter? You might get to about here in the other end.
I'm so stoked with how it looks. One final thing to do is to clamp down on some round bar. This is a 36mm offcut.
Oh, clamp down on some round bar. Yum, yum.
To be honest, even after all...
So that's 36mm, and he's pretty much maxed out here. You get 40 into it, I guess. Maybe. Yeah, you'd maybe get 40 into it.
The issues I've had with making this clamp, I still love every bit of it. With every mistake comes a lesson learned, and I end up hopefully improving a little bit more. Thank you to everyone who watches my videos. Remember, I'm trying my best to hit 10k subs this year. So if you like the videos I make, please consider subscribing. I'd also like to shout out to my Patreon and YouTube Fab Shop crew members, Roger M, Rick S, and Matthew B. Your generosity is...
People give this tool money. Good Lord.
Appreciate it more than you know. And until next time, I'll see you in the next one.
Well, yes, that was all sorts of dumb. 2 lathe crashes, beautiful, and I don't think there was a single piece of machining that he did right. Beautiful. See you later, kids.